Hello! We're going to do an example on how to sketch polynomial functions. The first thing you do, you look at your polynomial and you're going to decide what the degree of this polynomial is. How do we do that? Our degree is going to be adding our powers here. I have 3, 2, that makes 5, and 1 more, that makes 6. And we call our degree n. So we know that our degree is 6. The next thing you do is you determine if your degree is even or odd. In this case, 6 is odd. 6 is even. So this is a degree 6, which means it's an even degree. What do I want to know that for? That helps me determine my end behavior. The end behavior. When I have an even degree, the end behavior of this polynomial is going to mimic the end behavior of a parabola. When the degree is odd, it will mimic the end behavior of a cubic function. Okay? So mine is even. It will mimic this behavior. But you have to be really careful and make sure you look at your leading coefficient. That means the coefficient here in front. In this case, my leading coefficient is -1. We call that leading coefficient A. So in this case, in my case, A equals -1. That means A is a negative number. If A is a negative number, then this polynomial function is going to mimic my parabola, but an upside down parabola, because that negative in front tells you to reflect across the x-axis. So it will mimic this end behavior. Okay, this is the end behavior that my graph will mimic. It's going to fall to the left and fall to the right. If I have an odd degree and this is when A is greater than 0, and this is when A is greater than 0. This is for A less than 0, and when the degree is odd, this is the end behavior. This is when A is less than 0. So it's basically reflecting across the x-axis when A is less than 0, okay? Okay. So we know what behavior we're going to mimic. This one we have here. The next thing I do is I write out this function in expanded form. I'm going to solve for the 0. So when we solve, we write 0 is equal to, and I'm going to write this in expanded form so that you can see that these zeros are repeating themselves. X minus 2 is repeating itself 3 times. X plus 3 repeats itself also, and x plus 1. And now I can fill in a little table with all the information that I need. I can write zeros, I can write number of repetitions, and the multiplicity of the 0. I'm sorry if this is crooked. It's not easy drawing straight lines on this tablet. Okay. So we're going to deal with our zeros and the number of repetitions and multiplicity. For this 0 and this 0. Okay. Our first 0 is x minus 2. How do we solve that? We solve this by saying x minus 2 equals 0. So x equals 2. That is my first 0. How many times does this 0 repeat itself? Once, twice, 3 times. It repeats itself 3 times. So that means 3 is an odd number. So the multiplicity is odd. My next 0 is x plus 3. We solve by saying that x plus 3 equals 0. So x equals -3. How many times does this 0 repeat itself? Twice. 2 is an even number, so this is even multiplicity. My next 0, x plus 1 equals 0, x equal -1. This 0 only happens once. 1 is an odd number. This is odd multiplicity. You can also add to this table what's going to happen at the x-axis at each of these zeros. You can say x-axis. What's going to happen? When we have odd multiplicity, I like to think of this function, which is odd degree. This is x cubed. So when I have odd multiplicity, I think of x cubed. Why? Because thinking of that graph reminds me that this graph crosses the x-axis at its 0. So odd multiplicity means that this graph will cross the x-axis at this 0, x equal 2. Whenever I have even multiplicity, I like to think of the graph that has an even degree, which is x squared. And this graph reminds me that this line does not cross the x-axis at its 0. It touches it and goes back up. So this reminds me, whenever I have even multiplicity, this will not cross. Not cross. It touches. And again, odd multiplicity will cross the x-axis. Okay? I have all the information I need for now. I need one more piece of information, which is my y-intercept. For your y-intercept, this is what you're going to do. Y-intercept. What we do is we multiply all of these constants. But you have to raise the constant to that power. And also remember to use this negative in front because there's a -1 here. So I like to do it in my expanded form. That way I don't miss any of the constants. Some students will do -2 times 3 times 1. That's wrong because this -2 you have 3 times. So it's -2 cubed. So when you do it in expanded form, you sure won't miss any of the zeros. So let's start multiplying. I have -2 times -2 times -2. That's -8. -8 times 3 is -24. -24 times 3 is -72. And -72 times 1 is -72 times this -1 that's in front is +72. So my y-intercept is 72. And we're just going to use this number to reference it on the graph. We won't have space to find this y-intercept on a normal piece of paper. So we're going to scale it down, okay? We're going to scale the y-axis. And remember, this is an approximation. It doesn't have to be perfect. So remember that our intercept is 72 and that we found it by multiplying all the constants times that -1 that we have here in front. Okay? So now I can go and start sketching this, having all this information on the zeros and the y-intercept. So let's go ahead and do that. Let me open my other file. Right here. Here's my graph paper. Let's plot our zeros. I have a 0 at -1. I have a 0 at -1 right there. I also have a 0 at -3, and I have a 0 at 2. We already know by the end behavior we established that this was an even degree, but since this is negative, I already know I'm going to do it over here to the side. My graph should end up looking like that. at the end. It falls to the left and falls to the right. So that tells me that I begin from down here when I start plotting this. Okay, so I'm going to start from down here. I'm going to reach this 0, and I have to remember, do I cross it or do I touch at this point? Remember, this is my 0 here. This is -3. That comes from this one. It repeats itself twice. It's an even multiplicity, so I'm going to touch. I'm not going to cross. And you can use your table that you created on that previous slide. So I'm going to come from down here. I'm going to reach this 0, and I'm going to touch, and I'm going to go back down. I'm sorry about this. It's not easy. It's not easy drawing on this. So scratch this line here. Doesn't exist. I'm coming from here. I come up. I touch at the 0, and I go down. Okay? Now I have another 0 which is going to pull this line. It's going to make it come back up. How far down is this going to go? I don't know. I'm just going to go this far down. To figure out how far down I need to go, I would need calculus. We could also approximate it by finding a value in between these two zeros, but this value is not the peak of this graph, okay? So be very careful with that. For now, I'm just going to approximate and say I'm go this far down. I come back up to my next 0, who's -1, and -1 is odd multiplicity. So once I reach this 0 here, I know I'm going to cross. I'm going to cross, and I'm going to go up. And notice now I'm going to hit my y-axis. I hit my y-axis, and this is going to come back down, because remember, all zeros will pull your graph up or down. So I reach the 0. This is the 0, x equal to 2. This one right here, it's odd multiplicity because it happens 3 times. That means I will cross. Okay, and here is an approximation of what this polynomial graph will look like. It does have the end behavior that I predicted. My y-intercept occurs at a positive y value, and I would write here that my y-intercept is 72. And I have the graph with the 0 touching and not crossing, this one crossing, and this one crossing. I hope this makes sense to you. I have this graph plotted on WZ Grapher so that you have an idea of what it looks like. Here it is. This is the graph that we've just plotted. We started from down here. We touched, came back down at some point, and that point is actually, we came back down -65 on the y-axis. And then we go up, we cross at the 0, -1. We cross. Here's our y-intercept. Notice how my y-coordinate is 72, and I come back down to that last 0, and then it falls to the right towards infinity. I hope this video helps you understand this better. Make sure to review it, hit pause, rewind, fast forward, whatever you need to do. If you have any questions, you can post them online. Now I'm going to make the other video. Make sure you watch it, okay? I'm going to give you a graph like this, and you write the polynomial function. Take care, and I hope you study a lot.